For example 2, we're actually going to do 2b first, then 2a, and then 2a with a shortcut. But I want to do 2b and 2a regular so we get really good at the regular method. Because shortcuts are nice, but usually shortcuts only work in certain situations. And if all you remember is a shortcut, that means 80% of the questions you're going to get wrong because you can't use the shortcut in those situations. So we're starting off with 2b. Our brain should go first to the hard remember thing. If the hardest thing to remember is what you think about first, you need to change it to exponential form. In order to change it to exponential form, that only works if you have a single logarithm equal to a number. So it actually tells you what your first step has to be. The first step, we have to change it to a single logarithm. Sometimes, like in this one, your logs are on the same side. Sometimes they might put the logarithms on different sides. So you just have to move them over to the same side to do your log law. Do I have a log law for adding? Yes. If we're adding two logs with the same base and they both have a base of 2, then I can put them together by multiplying, and this will be x squared plus 2x when I multiply. The whole reason we got a single logarithm was to go to the weird step that's hard to remember. So we're now at hard to remember. I don't know if that's a good acronym. HTR. Hard to remember. Next, I say, oh, I'll change it to exponential form. My base is 2. The exponent is 3. It has to equal x squared plus 2x. And when I change it to exponential form, often it will turn into something that I've done in the past. Have you ever solved quadratic equations?
No.
No? All right, well then you must be in the wrong class. What do we do in quadratic equations? We make one side equal to 0. So I'm going to take this 2 cubed, which is 8. Don't write 6, please. 2 times 2 times 2 is 8. I'm going to move that to the other side by subtracting, and I get x squared plus 2x minus 8. What are my options now? Factor or quadratic formula, right? Most of these will be factorable, which is often quicker. It has to be x and x. Two things that give you 8, so then my outside and inside give me plus 2. 4 and 2 or 8 and 1? 4 and 2, because then my outside is 2 and inside 4. I need a plus 2, so I'll make my inside plus, my outside negative. Double check it. Do I still get the minus 8? Yes. So x equals minus 4 and x equals 2 are our final answers. However, this is a logarithmic equation. You always have to check your answers with your original equation. If an answer causes a number inside a logarithm to be negative, you have to cancel it out. We check minus 4, the original equation. First one, what's minus 4 plus 2? Minus 2. I don't have to check anymore. I can cancel that one out right away. Positive 2. What's 2 plus 2? 4. No problem. What's 2? 2. Also positive. No problem. This one is my final answer. I don't have to check and verify that it completely worked. That's not a bad thing to do, right? It's always good to plug in and actually do all the mental math to see that it works. Then you know for sure you got it right. But for checking, you just have to make sure that if something goes in that makes a negative inside of a logarithm or 0, because we have an asymptotic 0, then you cancel that out right away. The textbook actually does something a little bit bad in their examples. Question, Connor?
Will we ever get a question where both of the answers that we get
Are extraneous? Yes. Yeah, that's good. That's a good point because I'm going to bring up some trauma for students of about 8 years ago. 8 years ago, it was traumatizing. They went into their provincial final exam. The first question on their 3 hour plus extra half hour allowed, their first question on their 3 hour exam was solving for logs. And they're like, okay, I know how to do this. And they went through and they solved and they got one answer. And they checked that answer and it was a negative inside of a logarithm. And so they put an X through the only answer they got. And they're like, there is no answer? You really are going to do this to me on the first question of the exam? The first question of the exam, the answer was there is no answer. Few tears shed, turn the page over. I'm like, I'm already like that. You can do that. Question 5 on the exam, no problem, right? Like you don't gut punch the student right away on the first question of the exam. Like, you thought you might fail? Yeah. Think again. You are going. Like, that's what that was telling the students on that exam. They're like, why would they do that to us on the very first question? Yes.
Are you going to be at the exam?
I will be at the exam.
Okay.
Yeah. It's not like an AP one where they have somebody else supervise.
Right.
So, it can happen. Now, what I was going to say about the textbook, that the textbook does something a little bit bad. Did you see in example 1, we had 2 answers, and one of them we canceled out. We canceled out the -3 and said 3 was good. And this one we had 2 answers, and we canceled out the -4 and 2 was good. And you, as students, are very good at seeing patterns. One of the patterns that is not true that students start to see is like, oh, so if my answer is negative, can I just cancel it out? No. I could make a question where you get 2 positive answers and they both don't work. I could make it so the negative answer works and the positive one does not. And I can make it, you get 2 negative answers and they both work. I can create all of those situations. So just the fact that our answer is negative, that's not why we canceled it out. But if you weren't paying attention for a bit, you're like, oh, negative answer, cancel it out. We did that in the last one, we did that in this one. That's not why. You have to plug it into the original. And only cancel it out if the original makes it negative. So for example, if I got these 2 answers and my original was this. What happens when I plug in 2 now? What's 1 minus 2? -1. That would be bad. I'd have to cancel this out. What happens if I plug in -4? 1 minus a -4 is like 1 plus 4. That's 5. No problem. So I could make a log where you plug it in and the negative ones work and the positive ones don't. So I just want to point that out because sometimes as students we look for shortcut patterns and that would be a bad one to notice at this point. You always have to plug it back into the original. Okay. We'll now do part A. I'm going to show you the regular way first, and then show you the shortcut. The regular way helps us remember a few important facts. Okay. We're solving for x. The x is inside of a logarithm. The key to solving for it is changing to exponential form. And in order to change to exponential form, we need a single logarithm. How many logarithms do we have right now? 3 of them. Okay. Can you see on the right-hand side, you're subtracting? Do we have a log for that?
Mr. Junior, I think it's supposed to be a plus after the x plus 6.
Oh, thank you.
Yeah.
And there's supposed to be 2's, right?
Oh, yeah.
Oh,
Oh, Mr. Barrett, you know what they're doing?
yeah, I'm suffering from copyitis. I can't copy things down right.
There's no two.
There's,
That's on.
oh, I'm looking the wrong, that's on, oh, there is no. Definitely suffering from that really bad case of it. There is no twos. Oh, there we go. Whew. All right, class dismissed. I gotta go for therapy. Okay, well, we do have a log law for adding, right? And adding would be, I could multiply them together. You might notice I didn't actually multiply them out in my head. I'm suffering from a little fear and trauma that I might make a mistake. But do I have a single logarithm? No, I have one on one side still and one on the other. I need to combine it to a single logarithm. So in this case, to get a single logarithm, I'm going to have to move this over to the other side. Do I have a log law for subtracting? Yes, that's divide. I will multiply this out. You see that will give me x squared plus 7x plus 6 over 6x. So my log law for subtracting is I can divide.
Mr. Chicken,
It's mine.
you made another mistake.
I did? Oh, I did. Look at that. See, right now I'd like to see if I was testing you, but you know that that's not true. You know that it was x minus 1, right?
Yeah.
I just copied it down though. Which means that this, when I multiply it out, it's going to be plus 5x minus 6. Whew! Good now? Yeah? All right. Now I have a single logarithm. And I actually, for when you have multi-logarithms like this, if you want to go to the single logarithm, I probably would have suggested moving it over right at the beginning. And then you would have had log x plus 6 plus log x minus 1 minus log 6x. And you can use that shortcut and do it all together as a single logarithm in one step. The adding ones are always going to be in your numerator. The subtracting ones are always going to be in your denominator. Now we get to this step. Are you okay with the abbreviation by now?
Yeah.
All right. Can you remember what it stands for?
Hard to remember.
There we go.
Was I right?
Yep. Hard to remember.
I couldn't really remember.
What's it going to look like? What's the next step going to look like? Now we're stuck. No?
Base.
What's the base? 10. What's the exponent? 0 equals x squared plus 5x minus 6 over 6x. What's your zero exponent law mean? That's 1. So now we go to this grade 11 style of question. How do you solve a rational equation that has a fraction like this? What would you do first?
Multiply both sides by 6.
Multiply both sides by 6x, so it's no longer one of those equations. Okay, now we get this kind of equation. You saw what I almost did. Whew. What kind of equation is this? Quadratic. How do we solve quadratics? We make one side equal to 0. And then either factor or quadratic formula. Try to always factor first. It's quicker if you get it. If it's not working, give up on it and go to the quadratic formula. But can you say 6 and 1 or 2 and 3? Good. And I need negative x, so my outside and inside have to make minus 1. So my outside I'm going to make negative 3x, my inside plus 2x. double check it, multiply it out, sure enough, it works. And so we get x equals -2 and x equals 3 as our answers. And we always have to check log equations with the original. So I go all the way back to the original, check -2. If I put a -2 into this first one, is it negative? Yes. All right, that didn't take very long. Oh, surprise, surprise. This is where the textbook did a bad job. I think they should have had a question where they flipped it up a little bit, but it's okay. What about 3? 6 times 3, 18. Okay. 3 plus 6, 9. Okay. 3 minus 1, 2. Okay. It's close. This one's okay. That is our answer. Okay. Make sure everybody's done here. Now I'm going to split the page. Everybody good up to here? We're going to do the shortcut and see if you like the shortcut. There we go. Right back to the original question. On this side, I will label it as shortcut. The shortcut only works if you have log of something equals log of something. This is going to be the shortcut. And once we do step 1 that we did on the left, we are eligible for the shortcut. You've seen something similar to this shortcut before. I go, so if log of this, equals log of this, does it make sense to you that the 6x has to equal v, and if I multiply this out, and look at me go, not even making a mistake. If I multiply that out, does it make sense that the two insides would have to equal? If log of this equals log of that? That shortcut only works if log equals log. What's nice about the shortcut is look at the step we're going to skip. In fact, that shortcut, where does it, oh, look at that. That shortcut takes us from here all the way to that step without having to show any work. Woo! Now if you're doing like a game like Snakes and Ladders, that's like having a ladder that, and what you skip the HTR in the shortcut. So that's kind of nice. But the shortcut only works if you can make log equal to log. So in example, and that's all I'm going to show you in the shortcut, because once you go to here, everything would be the same, right? So you just skip 1, 2, 3, 4 steps by doing the shortcut. But it only works if log equals log. Look at the first question. It's not log equals log, it's just log equals a number, so shortcut is not available. There are some people who like the shortcut that they manufacture the shortcut. They change the 3, I'm going to change this 3 to log 2 of 8, and then I can go, so this has to equal 8, but it's not, it's actually longer in this situation. You have to do one extra step to change it to use the shortcut, and the shortcut gets you to the place in the other one that the hard to remember step would have done it originally. So I don't recommend it. But if you do have log equals log, you're fine. What's the danger is I could give you the same question A and add a +1 here, and the shortcut it's out. It's only log equals log. That extra +1 would throw everything off, and you would not be able to use that shortcut. So in some ways, be like, if you know the shortcut and know when to use it, perfectly fine. But be careful, because as soon as there's a single number anywhere, that shortcut's not happening. Okay, questions to circle on this one? 11 and 13.